we're going to get started by doing the warm-up where we balance out this equation. So I'm going to balance it with you guys, but if you guys, again, are confident doing any parts of this on your own, go ahead and balance it. Kind of zone me out for a sec, but I'm going to go through it step by step. Now, if we take a look at this equation, what are the two types of elements we have in it? Yeah, nitrogen and hydrogen. Good. Okay, so when we balance, what we want to do is we want to count how many of each element we have on both sides. We're going to count the nitrogens and hydrogens. Okay, so how many nitrogens do we have on the left side? 2. And how many hydrogens? 2. Good. Oh, there it is. It's louder. Okay, so we got 2 nitrogens and 2 hydrogens. Let's go to the right side. We have 1 nitrogen and 3 hydrogens. Now, the rules for balancing are you want to add to the side that has less of that element, and you want to add the whole molecule. So which side has less nitrogen? The right side, yeah. Hold up. The right side for you guys, that's my left. So the right side. So you need to add nitrogen onto the right side, but I can't just add nitrogen by itself. I have to add the entire molecule that it's a part of. So I have to add NH3. Okay, so if I add NH3, how many nitrogens are on the left side now? 2. And how many hydrogens? 6. Good. Okay, so the nitrogens are good, but the hydrogen is not balanced. So the left side needs more hydrogen, so I'm going to add hydrogen to the left side. So I'm going to add H2. If I add one of them, how many hydrogens are there? 4. So that means I need to add one more to get me to 6. Okay, so now all we need to do is put numbers in the front. I'm going to put a 3 in front of H2 because I have 3 H2 molecules. And I'm going to put a 2 in front of NH3 since I have 2 of those molecules. And there you go. This is your balanced equation. So hopefully that wasn't too bad. And I want to remind you guys, if you guys notice, I don't change anything about the equation. All I do is put numbers in front of the molecules to show how many we need. Yeah.
Why would nitrogen have to add NH3 for what hydrogen can add?
Yeah, good question. It's because if you take a look at the molecules, N is combined with H3 here, right? So that's one molecule. But H is a little bit easier. H is only bonded to H, so you can add the H2 together. But you have to add them in pairs. So I can't just add one H by itself. I have to add them 2 at a time. It's just the way the equation is given. It's like a recipe. Okay, any other questions on the balancing? Yeah.
All right. How can you put 2?
For the NH3 right here? Yeah, because I start off with 1 and I added 1 more, so that's a total of 2. So the number in the front tells us the total number of that molecule. All right. Any other questions? There are good questions. Yeah. 3 is because there's total of 3. I added 2 H2s to get it to 6, and there was 2 of them to start with. So 1 H2, 2 H2s, and 3 H2s. Yeah, it's the total number. Alrighty, so we're gonna go into talking about stoichiometry. Now, you guys don't need to write this down. I'll tell you guys what to write down and what not to, okay? So first of all, let's define stoichiometry. You don't need to write this part down. Okay, stoichiometry is just a fancy way of saying that we're gonna use dimensional analysis, so that fraction stuff, to analyze chemical equations. It tells us how much of a product that we could make using an amount of reactant. Okay, and I'm going to show you a problem because I think that's the easiest way to understand it. But I need you guys to write down these steps right here. Okay, when you're doing stoichiometry problems, which we will be for the rest of the year now, you have to follow these 3 steps. First thing you want to do is you want to balance the chemical equation. Okay, which we just did. So this is the problem we're going to work on, and you guys don't need to copy this down because we just balanced the equation. It's the same thing we just did. So step 1 is balance. Step 2, we want to find the molar mass of the involved compound. Okay, remember the molar mass are the numbers from the periodic table where you look at the bottom of the box and you add them up. So that's going to be in grams per mole. And that's how we find molar mass. This is what we learned last time. All right, and then last but not least, dimensional analysis, which is the fraction stuff that we talked about or that we've been doing for a while now. Okay, so the 3 things that we learned before today's lesson, balancing, molar mass, dimensional analysis, we're putting them all together and then we're going to do stoichiometry, which is how we're going to determine how much of a chemical we're going to make, how much materials we need to make a certain amount. And so basically, the lab next week is going to be based on this, and everything going forward is going to revolve around stoichiometry. Okay, so just make sure you copy that down, the 3 steps, and then we're going to apply the 3 steps right here. Okay. Alrighty, let's start the problem. So we already did the balancing. We already did step 1 in the warm up. So we have a 3 here and a 2 here. So you guys don't need to do the balancing. We're done with that. Now what we need to do is we need to find the molar mass of the involved compounds. Basically, what chemicals are we looking at? What are the important chemicals? So let's take a look at this question. Okay, if 12 grams of N2 gas reacts with excess H2, how many grams of NH3 will be produced? Now, we talked about this briefly last time, but does anyone remember what excess means? Yeah, you have a lot, but even more than a lot, you have so much. Yeah, more than enough. You don't even need to care about that chemical. So we say we have excess H2. So does that mean we care about H2 in this problem? No, we're not going to care about H2. So what that means is the involved compounds, the important chemicals are going to be the other 2, N2, because if you guys notice, our given number, I'll write it right here. The given number is 12 grams of N2. So N2 is very important. And we're looking for how many grams of NH3. So what we want to end up with in this problem is going to be grams of NH3. Okay, so that makes sense. We start with N2, so that's very important. And we want to end with NH3, so that's also important. Those are the 2 chemicals that are important in this problem. Okay. I'm recording this up here. Baby, thanks, appreciate it. Alrighty, guys. Any questions on how we found the important chemicals? Okay, so we did step 1, we balanced. And so what we're going to do now is we're going to find the molar mass of the important chemicals. I want you guys to take about 2 minutes. You could work with the person next to you. I want you guys to find the molar mass of the important chemicals, N2 and NH3. Okay, take about 2 minutes to do that. Yeah, what up, Amir? Did you have a question? Yeah, all right. Yeah, what up? Hold up, wait, let me pause real quick. Okay, I'll give you guys 30 seconds to finish it up. Molar mass of N2 and NH3. Okay, guys, let's do the molar mass. So we have N2 and NH3. So if you guys take a look at the periodic table, we have N. Okay, nitrogen is 14. Okay, so if you look at N2, we're going to have to do 14 times 2. So what's the molar mass of N2? What's the molar mass of N2? Nitrogen is 14. So if I have 2 of them, it's 28. Yeah, 28 grams per mole. Are you guys all nervous because I like hyped up this type of problem? Oh, okay. Okay, so nitrogen is 14. And so if we take a look at hydrogen, what's the molar mass of hydrogen? Yeah, 1. So let's think about this. Nitrogen is 14, hydrogen is 1. And if I have 3 of them, what's the molar mass of this entire molecule? 14 plus 1 plus 1 plus 1 is, yeah, 17. So it'll be 17 grams per mole. Okay, so now we did step 2. We found the molar mass of both of the chemicals. Okay. All right, I'll pause right there before we finish up this problem. Any questions on the first two steps? Okay, the last step is to do dimensional analysis, and I'm going to give you guys some ways to make it a little bit easier. So for dimensional analysis, we're going to start by writing the starting number. The starting number is 12 grams of N2. So we're going to start by writing 12 grams of N2. Okay, now, when we do stoichiometry, you will always do 3 fractions, okay? At least for this unit. So we're going to start by drawing 3 fractions, and all we're going to do is fill in the fractions, okay? So draw 3 fractions, and all we're going to do is fill it in. Now, I'm going to show you guys how to set it up a little bit easier so you guys don't need to, so you can just memorize how to do it. So we always do 3 fractions, and if you guys take a look at the tops of the fractions, we can figure out what to put on the tops by remembering a very important sound, okay? And I want you guys to burn this into your memories and to say it out loud after me, okay? You guys ready? So the sound for stoichiometry is gamumaga. Okay, so I'm gonna say it again, okay? Gamumaga. Can you guys all repeat that? Gamumaga. Louder. Gamumaga. Gamumaga. Yeah, so gamumaga. So weird sound, but this is what gamumaga stands for. And guys, I have kids that come back 2 years ago, and this is the only thing they remember about chemistry. It's gamumaga. So gamumaga is ga, ma, ga. Okay. Now, the reason why we use the sound is because if you look at tops of the fractions, grams is ga. M goes on the top of the second fraction. Third fraction is m, and then the last fraction is g. So that's gamumaga. Okay. Hopefully that helps you remember. So g is grams, right? What do you guys think m is? Yeah, moles, right? So we're gonna put moles. Yeah, the only thing that starts with M that we're really talking about right now is moles. So it's going to be grams, moles, moles, grams on the tops of your fractions. Okay, gamumaga. Gamumaga. Okay, and then last but not least, before we start filling in the fractions, we want to end with grams of NH3. So that means the last fraction will be grams of NH3. And now we have all the setup. We just need to plug in the fractions, and then we'll be all done once we calculate. Okay, so from here, everything that we have, we already know how to do. I have grams of N2, and I want to get rid of it. So if I want to get rid of this, what should I put on the bottom of the fraction next to it? Yeah, I have grams of N2. I want to get rid of it. So what should I put on the bottom right here? Yeah, G of N2. Okay, the exact same thing. That way, remember, they can cancel out with one another. Now, if you guys notice, there's grams and moles on the same fraction, right? Do you guys remember from last time what I told you about a fraction with grams and moles? Where do I get the numbers from? Gosh, you guys don't remember what I say? It makes me so sad. We get it from the molar mass. Okay, so just make sure you guys jot that down. If you have a fraction that has grams and moles on the same if you have a fraction with grams and moles on it, you always get the numbers from the molar mass, okay? Which means that we're going to be talking about moles of N2 here. It's okay, guys. I'm not too sad you guys don't remember. I wouldn't remember either. Okay, so the molar mass of N2 is 28. So where should I put 28 on this fraction, top or bottom? Okay, so if we look at the number 28, what is right next to 28, grams or moles? Grams. So where should I put 28 on this fraction? Yeah, bottom, because it needs to be next to grams. 28 is next to G, so I just put 28 next to G. Okay. And then since it's molar mass, what number goes next to moles? 1, yeah, because it's grams per mole. And there you go. We've filled out our first fraction, and we can cancel out the grams. So the grams here can cancel out with the grams here. So that's the first fraction. All right, let's move on to the second fraction. I have moles of N2 and I want to get rid of it. So what should I put on the bottom right here? I want to get rid of moles of N2. So how can I get rid of it? Yeah, you put the same thing on the bottom and that way you can cancel it out. And then on the top, I'm going to put NH3 because we want to turn it into grams of NH3. So it needs to be the same chemical right here. Okay, now if I have a fraction with moles and moles, can you put it next to the clipboard? Thanks. If I have a fraction with moles and moles on it, you're going to get the numbers from the balanced equation. Okay. So the second fraction, you get the numbers from the balanced equation. So this is similar to what we did when we first learned about balancing. What number is in front of NH3? 2. So I'm going to put a 2 on the top next to NH3. And what number is in front of N2? Yeah, if it's blank, it's 1. So we put a 1 next to N2. And the moles of N2 will cancel each other out. All right, and then last but not least, we want to get rid of moles of NH3. So we put it on the bottom right here. That way they can cancel out. And if you guys notice, what's on the same fraction? NH3, but it's also grams and moles. So if I have grams and moles on the same fraction, where do I get the numbers from? Yeah, molar mass. There we go. Okay, so what we're going to do is we're going to take the molar mass of NH3. We're going to put it into this fraction. What number is next to, what number should we put on the top? If it's grams. 17, good. We put grams on the top. 17 is next to G, so we put it next to G. And what number should I put on the bottom? 1. There you go. Now that's how you solve or fill out every single fraction. Now we just need to do the math and we're all done. Okay, so I know that was a lot. This is all still one question, guys. So I know it's a lot, pretty difficult. So I'll stop right there before we do the calculations. But do you guys have any questions about any part so far? A lot? Yeah.
So how is 17 the molar mass of NH3?
Because when we went to the periodic table, remember nitrogen is 14, hydrogen is 1. So we just said 14 plus 1 plus 1 plus 1. And that's how we get the molar mass of NH3. Okay. Any other questions? Don't worry, guys. It'll get better as we do more practice problems. I'll make sure to give you a lot of practice problems. Yeah, you don't need to lie to me like that. Okay, let's solve it out now. Okay, so when we do the math, I need you guys to just remember that the numbers on the top you multiply and the numbers on the bottom you divide. So if you look at 12, 12 is our starting number. So I'm going to, down here, I'm going to put in exactly what I'm going to punch into the calculator. I'm going to write 12. Okay, 28 is on the bottom. So what do I have to do with 28? Divide. So 12 divided by 28. You can always ignore the ones because they don't really change anything. 2 is on the top. So what do I do with the 2? Multiply. And then what should we do with the 17? Multiply or divide? Yeah, multiply times 17. And so that is exactly what I punch into the calculator. 12 divided by 28 times 2 times 17. 12. 28 is on the bottom, so we divide it. 2 is on the top, so we multiply it. 17 is on the top, so we multiply it. Okay, so if I punch that into our calculator, we'll get our final answer. 12 divided by 28 times 2 times 17. Final answer is 14.571. So the final answer to this problem is 14.571. And since I have grams of NH3, that's what I was looking for. It's going to be grams of NH3. All right. You can. I like 3 numbers after decimal because it'll help you out with so that you stay accurate as you do calculations. But if you do 14.6, I won't mark it at all. All righty. That's one problem, guys. Any questions? We're gonna do one more. I'm gonna let you guys try one on your own, and then I'm gonna let you guys get started on the side. Yeah.
Where did you get 12?
Which 12? 12 is our starting number right here. Yeah. Yeah. 28 is on the bottom right here, the molar mass of N2. 17 is the molar mass of NH3. We just went to the periodic table and added up the parts. So if you look at N is 14, so 2 of them is 28. All right, we'll try one more problem. I'm gonna give you guys some time to do the balancing on your own, and then we'll start going over together. But if you feel confident just going ahead, feel free to do that as well, okay? So the first step when we have a stoichiometry problem is you want to balance. So take about a minute or two to work with the person next to you. Try balancing this. If you guys are confident going on, finishing the rest of the problem, feel free to go ahead and try it. But I'm going to take it step by step in just a second. But at least try to get the balancing on your own. Alrighty, guys. So I'm gonna start going over the balancing just so that you guys have time to work on the assignment today. But if you guys again feel confident trying it, just you can zone me out for a bit and finish up the problem. So for the balancing, all you really had to do was you had to put a 2 in front of here and 2 in front there. I'm not gonna go over all the steps because by now you guys should be pretty good with the balancing. But any questions on the 2's that we put in? Okay. All right. Okay, so step 2, we said that we want to find the molar mass of the important chemicals. So it tells us here that we have excess O2. So that means O2 is not important. And so the important chemicals here are H2 and H2O. Okay, so let's find the molar mass of H2 and H2O. We said earlier that H2 has H has a molar mass of 1. So if I have 2 of them, what's the molar mass of H2? Yeah, 2. You just need to do 1 plus 1. So H2 is 2 grams per mole. Now for H2O, it has 2 hydrogens and 1 oxygen. So we know the hydrogen is 1. So if we look at oxygen, the molar mass of oxygen is 16. So that means the molar mass of water, H2O, is going to be 1 plus 1, because there's 2 hydrogen, plus 16. And what's the molar mass of H2O then? Yeah, 18 grams per mole. So that's step 2. Step 2 is just finding the molar mass. All right, Now for the last step, we need to do our dimensional analysis. So I'm going to do that down here. Okay, let's figure out our starting number. What's our starting number in this problem? Yeah, 40 grams of what chemical? H2. So our starting number is 40 grams of H2. So far, so good? How many fractions are we supposed to set up? 3. So we set up 3. And then what's the sound that we use to do the tops? Are you guys embarrassed to say it? What's the sound? Yeah, gamumaga. Gamumaga. So grams, M, G, and then we said the M is moles. So gamumaga. Grams, moles, grams. Hey, what's up, Mr. Pepper? Hold up. Give me a sec. Okay, anyway, so we have gamumaga, so let's start plugging in what we have. So we start with H2 gas. What do we want to end up with? Grams of what? Yeah, H2O, grams of H2O. So that's what we're going to end up with right here. So we want to find grams of H2O gas, so that's what we put at the very end of the fractions. Okay, now we just need to plug in what we have into the equation. So I have grams of H2. If I want to get rid of it, where should I put it on this fraction? Yeah, bottom. So I'm going to put grams of H2 on the bottom. And that's going to be moles of H2. Drake, close your Chromebook. Okay, so we have grams and moles on the same fraction. So if I have grams and moles on the same fraction, where do I get the numbers from? Molar mass. Good. So we get molar mass. So all we need to do is go on the information that we calculated earlier. Molar mass is 2. So where should I put the 2 on this fraction? Top or bottom? Bottom. Good. Because it's next to G, grams. So we put it next to grams. And what number should I put on the top? 1. Good. Dude, you guys are getting this quick. It's impressive. All right. What should I put on the bottom of this fraction? Yeah, moles of H2. And then on the top is moles of H2O. Good, because that's what we're trying to find. Sorry, I wrote H2O on the bottom right. My bad. Okay, if I have moles and moles on the same fraction, where do we get the number from? Yeah, the balanced equation. The balanced chemical equation, the chemical equation, however you want to say it. Okay, so what number is in front of H2O? 2. So we put a 2 on the top and then 2 for the H2. So 2 goes on the bottom as well. And so that allows to cancel out the moles of H2 with one another. But we can also cancel out something else. What else can we cancel out here? Yeah, the 2's. Because if I have a number on the top and bottom, they can cancel out just like how we can cancel out the units of measurement. So this fraction is basically going to disappear. We don't need to worry about it because the numbers are gone. There's no math to do there. And then lastly, we're going to put moles of H2O on the bottom. And you guys already told me, but if I have grams and moles on the same fraction, where do we get the numbers from? Molar mass. Good. And then lastly, we just need to bring down the number for the molar mass, 18. And that's what we put into the last fraction. So where should I put 18 on this fraction? On the top. Good, because it's next to G. And then 1 goes on the bottom. These cancel out. And there you go. We're all done. And we just need to punch it into our calculator. So I know it's a lot of steps, but it seems like you guys know the individual components. The hard part will be just memorizing and remember what order to do the steps in. And this might take a while to get, but it's okay. That's why we're taking the exam for this unit in the middle of January at the end of the semester. So you guys have a lot of time to learn it, a lot of time to forget it during break, and then you can come back and remember it again. Okay. Okay, let's plug this into the calculator and we'll be all done. Okay. Okay, our starting number is 40. What should we do with the 2 in the first fraction? Divide. And then we said we can skip this fraction because everything got crossed out. And then what should we do with the 18? times 18. Final answer is 360. So that means in this equation, we're going to make 360 grams of H2O. And there you go. That is the answer to this problem.
Like, what is the sugar hold that?
Huh?
Like, what is the sugar hold that with water?
360 grams of water is very little. It's like less than half a liter. Okay, so I'm gonna give you guys the rest of class period to work on this assignment. I have recorded this lecture, so it will be uploaded on Canvas. If you need it to kind of refer back to, I'll also leave the screen up here so you guys can look back at the steps and how we did it. But if you want to check your answers at any point, ask me any questions. I'm more than happy to help you guys out, okay? So good luck on your assignment, and let me know if you guys have any questions.